Hello, let us start our discussion about the modulation of the color difference signals, and I am presenter Mrs. Suvarna Kadam. Now, to understand the color difference signal modulation, we have already talked about the color subcarrier signal, which is nothing but if I take the example of PAL system, it will be 4.43 megahertz, and the modulation technique we are using is nothing but the quadrature amplitude modulation. So when I talk about the quadrature amplitude modulation, I mean that whenever I am transmitting my signal, I am using a modulation which is having both a modulations, that is quadrature means I have a phase modulation and I have a amplitude modulation. So for a different colors I have only one color subcarrier. The frequency will be same for each and every color, that is 4.43 megahertz, but the theta will be changed for each and every color, and then amplitude, that is color subcarrier, or you can say I'll just denote it with a C, will be changed for each and every color. So there is the change in the phase and there is the change in the amplitude which defines which color you are transmitting. So if you see the resultant of the color, which is nothing but the square root of r minus y square plus b minus y square. So this is the red color difference signal, this is the blue color difference signal, and if you want to find out the phase for any color, your formula will be tan inverse of r minus y and b minus y. Now we'll take one example of any color and then we'll calculate all these things to find out how this particular thing happens over there. So I'll take the example of red color first and then we'll go for yellow color. So you are having on x-axis b minus y, positive x-axis t, and here you are on y-axis you are having a r minus yt. So the location of r minus y and b minus y subcarrier phasors are given here. Then your resultant will be r minus y square plus b minus y square, which we have seen in the previous slide, and your phase will be tan inverse of r minus y and a b minus r minus y divided by b minus y. So this amplitude is nothing but the CT, which shows, this amplitude shows the saturation of your color. Yeah, you can say in very simple word, this is nothing but the color, and this particular phase shows the hue of your color. Okay, so if the phase error is there, there will be the change in the hue. If the amplitude error is there, there will be the change in the color or saturation of your signal. Now I'll take one example over here where I'm just trying to find out which color and how that particular things will look like. So first I'll take any basic color and then I'll talk about any basic color means primary color. So I'll talk one primary color and then I'll talk about one secondary color. So I'll take one primary color. So one primary color, let us take red color here. So I want two components. I want r minus y and I want b minus y. So here r minus 0.3 r minus 0.59 g minus 0.11 b, because I know my luminance is equal to 0.3 r plus 0.59 g plus 0.11 b. Just I have put it that things over here. So my red color will having only red component, no other components, so it will be not there, this will not there, and this component will be 0.7 because I'm putting r is equal to 1. What about b minus y? b minus 0.3 r 0.59 g 0.11 बी माइनस, तो यहाँ पे आपका बी तो नहीं है, आपका जी भी नहीं है, आपका पी भी नहीं है, क्योंकि आप सिर्फ प्योर रेड के लिए बात कर रहे हो. सो दिस विल बी 0.3. हाउ आई एम गोइंग टू कैलकुलेट द रिजल्टेंट फॉर दिस वन, आर माइनस वाई स्क्वायर विच इज 0.7 स्क्वायर प्लस 0.3 square which is minus. So if I calculate these things, I'll get 0.7 sorry 0.7 square plus 0.3 square and the square root of my answer. So it gets 0.76. So if I'm going to find out the resultant for this one will be 0.76. What about theta? Tan inverse of r minus y, which is nothing but the 0.7 divided by 0.3, which will be minus. Okay? So if I'm going to find out the tan inverse of this particular angle, so I can say which is nothing but the 0.7 divided by 0.3, and which comes here 66.8, and that angle will be negative angle, so minus 66.8 degrees. So I can say for red, if you're going to show it on the color circle, you will have here b minus y, here r minus y, you will have minus b minus y, you will have here minus r minus y. So your resultant is 0.76. What is your r minus y component? It is 0.7. So it's positive, means यहाँ पे, negative means यहाँ पे आएगा, ठीक है. And your angle is minus, so you are going to start from here. So the amplitude is 0.7, your angle is minus 66.8 degree. तो आप minus मतलब आप anti clockwise जाएंगे, plus है तो आप clockwise जाएंगे. So this is nothing but the location of your red color. Now how the quadrature amplitude modulation for red color takes place? So your luminance associated with red color will be only 0.3. So your chrominance gets superimposed on your luminance. So this will be the 0.3, I'll say luminance, plus 0.76 minus 0.76. So ये जो भी है आपका plus 0.76, and this will be, I'm just showing it below thoda sa, and this will be 0.76. ठीक है. Now you can say 3 plus 0.76 will be 1.06. So this type, and this wherever it starts is nothing but the minus 66.8 degree. So this is how quadrature amplitude modulated signal for red color signal is shown in this particular. Now we'll take any example where here, whereas we are going to talk about the another color which is nothing but the secondary color. So when I say secondary color, you can take the example of yellow color. So yellow is the combination of red plus green. So what is the luminance associated with it? 0.3 R plus 0.59 G plus 0.11 B. I don't have this B component in my yellow color, so I'll have luminance 0.89. What about the chrominance? That is R minus Y. So R minus 0.3 R minus 0.59 G minus 0.11 B. So I don't have B. So 1 minus 0.3 minus 0.59. Okay, so this component comes plus 0.11. ठीक है. What about the B minus Y component here? So if I'm going to talk about the B minus Y, it's B minus 0.3 R minus 0.59 G माइनस 0.11 बी. बी और बी को आपको निगलेक्ट करना है क्योंकि उसमें वो नहीं है. सो माइनस 0.3 minus 0.59, it comes minus 0.89. So if I'm interested in the resultant, it is say 0.11 square plus minus 0.89 square. ठीक है. So if I am putting all these things over here, and if I am taking the square root of this answer, I get 0.89. So if I am interested in finding out how that quadrature amplitude modulated signal will look like for this, then I'll draw the QAM signal. Your color subcarrier will be 4.43 megahertz and luminance will be 0.89. On that 0.89, which is approximately equal to 0.9, you are superimposing your color subcarrier here, or you can say color subcarrier. ठीक है. And amplitude of this particular is nothing but, I'm trying to draw it to give you the idea. So this particular amplitude will be 0.9 and this amplitude will be 0.9. Now you can imagine, as we are talking about the quadrature amplitude modulation, the modulation index should not exceed more than 1. But here your modulation index point, this is close to 0.9, so near about 1.8, 80% over modulation you will observe here. ठीक है. We'll talk about the theta here. So tan inverse of, you can take r minus y, that is 0.11 minus 0.89. So if you are taking the tan inverse of say 0.11 divided by, what is that, 0.89, it comes minus 7 degree. So if you see this minus 7 point, I think it is coming 0.4 degree. Okay, so angle will be, now how this particular signal will be located here, this is my B minus Y, this is R minus Y, this is minus B minus Y, and this is minus R minus Y. आपका R minus Y component is positive, यहाँ पे your B minus Y component is negative, so it will be 0.89 here, and 7 degrees. 7 degrees is again negative, so it will be somewhere here in very small amount, and this amplitude will be 0.9 here. ठीक है. So this is how you're going to show your yellow color on the color circle. Now let us move further. So each and every color, as we have already calculated, this is 0.76. Our angle is nothing but the 66 degree. Similarly, you can go for blue color and a green color. Then we have done for I think yellow color. So this is 0.11 r minus y. This is this one, and you can see amplitude and this angle they have not shown here, but it is a 7-degree angle. So as we have already mentioned, that whenever you're going for the quadrature amplitude modulation, your outputs or your amplitudes or your modulation index exceed 1, and then we will see how we can work on that. First we'll see location of the color burst. So we have already aware of the composite video signal. This is front post, this is sync, and this is the back post. So this is complete horizontal blanking interval of 12 microseconds. So if you do remember what we have seen previously, this is a 12 microsecond complete duration. You are having this front post of 1.5 microsecond, the sync will be 4.7 microsecond, and you are having the back post duration of say 5.8 microsecond. Okay, so you are putting the color burst. Now how you are going to understand whether your information where your signal is color or black and white? So the color burst signal is put it, that is 8 to 11 cycle of 4.43 megahertz subcarrier will be placed on the back porch of that particular horizontal blanking interval. So if the color burst present, you can say the signal or the transmission is a color transmission, and if it is absent, you can say that transmission is a black and white transmission. I can't say black and white, it's a monochrome transmission. So this is all about the location of the color burst, and as we are already aware of, I think I have already calculated that the luminance associated with yellow color is 0.89. Then you are superimposing the subcarrier amplitude, that is 0.9 and zero point 0.9. So you find here this is the limit, that 33% over modulation you are allowing, but this is the limit, and this yellow color, your cyan and your I can say green color, they are exceeding your over modulation, or they are exceeding your modulation limit, which is called as the over modulation, and which is not feasible in the transmission. So generation, here they have shown you the composite color signal for a theoretical 100% saturated 100% amplitude color bar signal as seen from the relative amplitude scales. So you can see the composite video signal will cause cross over modulation. Therefore in practice the color difference signals are reduced in amplitude to avoid any excessive over modulation. So ye how much over modulation is allowed? 33% over modulation is still allowed, but they are exceeding that 33% also. Okay, so what is done here, instead of putting, you are transmitting b minus y and r minus y as they are generated, they are weighted by some factor. Okay, so if you'll see your b minus signal, y signal will be weighted by 0.493. ठीक है, and your r minus y signal will be weighted by 0.877, and this is what we called as, if b minus y is weighted, this will be called as a u, and this will be called as a v. So your color subcarrier will be u square plus v square. ठीक है, so if you scale this 0.89, दिस इज द ल्यूमिनेंस, v माइनस वाई को अगर आप 0.493 से स्केल करेंगे, यू विल गेट दिस वन, दिस इज अ वेटेड कंपोनेंट. अगर आप 0.11 वेट करते हैं 0.877 से, तो यू विल गेट, सॉरी दिस इज yeah, this is r minus y, इसको तो point, and the resultant you will get is nothing but the 0.44, and if you put this new values over here, you will get this kind of the things. ठीक है, so अगर आप यहाँ पे देखेंगे, if you'll see here, your over modulation limit does not exist, because 0.89 पे 0.44 है, यहाँ पे 0.44 है. ठीक है, तो 100% modulation is achieved. So 100% saturated, 100% amplitude color bar signal in which the color difference signals are reduced by weighing factors to restrict the chrominance signal exertion to 33% beyond black and the peak white levels. तो आपका ये peak white है, आपका ये peak black है, उसके beyond 33% they are allowing, but not more than this one. ठीक है, so you can see this is something which we have done to avoid the over modulation, to exceed or to avoid the exceeding the ranges from 0% to 100%, and this concept is very much important, which is called as the weighing factors. Whatever you are doing, what you are doing in this particular b minus y signal, you are doing u is equal to 0.493 b minus y, and v is equal to 0.877 r minus y. And this factor, so this particular signals will, or these factors will be called as a weighing factor, and these signals will be called as the weighted signals to avoid the over modulation. Now we can see how the magnitude and phase relationship of compensated chrominance signals for primary and secondary colors. So you can see रेड आपको पहले ही मिला था 0.76 पे, ठीक है, तो अगर आप वेट करते हो तो आपको ये 0.63 पे मिलेगा, और आपका जो भी एंगल है दैट विल बी टू द 76.5, एंड दैट विल बी, यू कैन से negative, and that's why they have shown here like this. So if you want to know how that particular things are calculated, we can go in the previous calculations which we have done previously for the red color. So here it's for yellow, then we'll go for the red color. So if you can see, you can weight this factor with the 0.877, and you can weight this factor with the 493. So new components, whatever you will get is nothing but the like sometime. So 0.7 into 0.877, which becomes 0.61. So I'll write here 0.3 into 0.493, which becomes minus 0.1479. And if I square this to get my color subcarrier, the square root will be 0.62. So if I put C is equal to U square plus V square, means these two factors square, I'll get this 0.62. So this is the new color subcarrier or new color amplitude when you are weighing that particular signal. And what about the theta? You just simply put theta is equal to tan inverse of V by U. So you can put tan inverse, and what is the V in this particular case? We have calculated is like minus 14, sorry, it's r minus 5, so this will be 0.61 divided by minus 40, so 14. So if you do this one, you will get another angle, that is, I just calculate 0.61 divided by 0.147, so this angle comes minus 76 degree. So if you see in whatever I have shown you right now, your weighted factors are 0.61 minus 0.14. So for red color only we'll try to understand these things. I'll just move forward again, which we have seen here in this. So if you see for red color, you are having minus 148 b minus y, and you can see r minus y is plus 614, and resultant is 0.63, which is close to 0.62. Okay, and your angle will be minus 76. So in that red color, you can see here on the polarity that your amplitude is 0.63 and your angle is near about 70. As this is negative angle, you are moving from here to here. If it is positive, you need to move from here to here. Okay, so this is nothing but the how we are going to show any color on your color circle. So this is all about the QAM, quadrature amplitude modulation. We will stop here. Thank you.